Hello guys, this is Untitled Cap, and today we are going to review a paper, Dynamics of Dark Energy with Coupling to Dark Matter. In the previous video, you can find in the I button that if the dark matter and dark energy are talking to each other or they are interacting with each other directly, I explained the meaning of what is the meaning of directly there. You can see and find the video there. So the Hubble tension can be elevated. I'm not sure, I'm not saying that whatever the idea they have presented, that it is the only way one can elevate the dark energy, but it is one of the possible way. So in this paper, they have found that they have presented the idea that how the dark matter and dark energy can talking to each other or interacting to each other, and what is the meaning of it. What you can understand from here, so let us just first study this abstract. Dark energy and dark matter are the dominant sources in evolution of the late universe. They are currently only direct via the gravitational effect, and there could be coupling between them without violating the observational constant. We investigate the background dynamics when dark energy is modeled as exponential quintessence is coupled to dark matter via simple models of dark energy exchange. We introduce a new form of dark sector coupling which leads to a more complicated dynamical phase, has a better physical motivation than previous mathematically similar couplings. Okay, so what I want to say is, first of all, we have some kind of basics. We understand that our universe is homogeneous and isotropic. Therefore, we have this kind of, we are saying that our universe is more or less flat. So this is the scale factor, and this is the time variable, the coordinate time, and we are having the action to be like the total action of the system is d4x square root of minus g, and this g is determinant of the metric term and the Ricci tensor, and this kappa is corresponds to kappa square, let us say 2 kappa square, and this kappa square is 8 pi g. And then we have some kind of a perfect fluid, and the perfect fluid for this action is denoted by Sm. And then we have this simplified, let us say, you can say that square root of this action of phi, okay, and this action of phi is with some square root of minus g, and we can, and this is the simple minimal coupling. This is kind of a minimal coupling where every component of fluid and field is coupled with the gravity, means that there is only multiplying with square root of minus g. This is called minimal coupling. Now we have introduced a non-minimal coupling, and what we have given the argument that now because of this we will get the two Friedman equation, 3h square is equal to kappa square, the rho total term, and 2h dot plus 3h square is equal to minus kappa square, the pressure, the total pressure of each component. Okay, and there is one more equation from the Bianchi entities. We have this energy momentum tensor is conserved, which says that if you have the let us say cold dark matter, then you got 3h rho plus p is equal to 0, rho pc, and similarly rho phi dot plus 3h rho phi plus p phi is equal to 0. Okay, now if you have the interaction between them, they are not individually conserved, but they have the term which is minus q, and there is called plus q. Okay, so we will see in a minute that how this is actually helping us, and we will understand about the dynamics of these terms. Now when I say about dynamics, we are talking about the dynamical feature of the system, and to understand the dynamical feature of the system, I have also made a video, you can see and check it out. And dynamical feature of the system can be seen from the mathematical point of view, where we are introducing some variables which is dimensionless. So let us say x and y are dynamical variables, and therefore we will find that dx by dt, and this dx by dt can be written in terms of only x and y. And similarly, dy by dt can be written in terms of another function which is composite with x and y. Okay, in this regard, our differential equation is closed, and from here we will talking about the stability, and we try to understand every cosmological parameter in terms of only x and y. That is the meaning of dynamical study, and from there we will infer that what kind of system, what kind of study we will, what kind of physical things we will get to understand. Now, in order to understand about the quintessence, they have taken the potential term, because you have to understand, you have to invoke the potential term from yourself, and from this study they have taken the exponential term. So the potential can be like phi square term, or maybe 1 by phi square term, or maybe exponential of phi. Okay, now this exponential of phi have very interesting feature that as the field is evolving, or a system is actually going to dark energy sector, then this potential becomes kind of flat. And when you have the you have the radiation domination or the dark matter term, this phi is basically rolling through this hill. And in the inflation, again, there was the potential to be kind of flat one. Okay, so that is kind of a characteristic. If the potential have this kind of characteristic, then it will surely invoke the acceleration scenario in the late time. We will talk about in later in a minute. So this is kind of an this potential discussion is out of the scope for this point of view. Okay, for this point of time. Okay, now what we are understanding here is that what they have taken first of all potential. Now they have taken that, okay, what we are going to introduce here, that rho c is corresponds to cold dark matter and rho phi is corresponds to quintessence field. And if you are here like rho c plus 3h, rho c is equal to minus q, so they have taken in this right hand side. And similarly you have, now they have said that if q come out to be greater than 0, the energy transfer from dark matter to dark energy, or if come out to be negative, therefore dark energy to dark matter. That is the scenario. It depends on you how you are choosing it. Now we have already seen that dark energy, there is an equation of a state parameter called omega phi or w phi, which is p phi over rho phi. In quintessence, it came out to be half phi dot square minus v phi and half phi square plus v phi. Okay, and then if you have the field in scenario, therefore you can vary your action with respect to phi, and there will be the field equation of motion. And this field equation of motion is coming out to be this one. If there is no q term, this is coming out to be 0, and there is a q term, therefore this is come out to be q by phi dot. Okay, and because we have already said that rho phi plus, because of this thing, okay, because of this equation 4, this has been modified, like equation of 7 have been modified because of the interaction. So you can say that if you are invoking any kind of interaction between dark matter and dark energy, then you can easily say that your two equations, the conservation equations and the equation of motion corresponds to field, gets modified. So if you have quintessence field, it will modified, maybe Chaplin gas, maybe any kind of scalar field, it will be modified. Okay, now suppose you have another thing, like universe has come from radiation to baryonic matter, ordinary matter. We are assuming that if you have these kind of fluids, this kind of matter, they are kind of baryonic matter, therefore their energy momentum tensor is conserved. Okay, so it means the dark energy is not directly talking to any of the baryonic matter or the radiation. So that is means, so therefore they are completely conserved by their own. So we can say that if you have ordinary matter, let us say ordinary, rho dot is equal to minus 3 rho ordinary plus p ordinary. Okay, p ordinary. So p ordinary for pressureless fluids coming out to be 0, and for radiation this coming out to be rho ordinary. Therefore you will get equation number 9. Now we have already find that here that the first Friedman equation is corresponds to kappa square, the total density. So if you have total like rho r plus rho baryon plus rho cold dark matter, and here rho of phi. Okay, and the second Friedman equation is coming out to be this one. Now second Friedman equation we have talked about 3h square, and if you are just replace 3h square by the first Friedman equation, then you will eventually arrive at equation number 10. Now here we have introduced some kind of dimensionless quantity for the energy density term, because you can see here 3h square is equal to kappa square some rho term. So if you are dividing with this thing, 1 is equal to kappa square rho by 3h square. Now we already know that 1 is a dimensionless quantity, therefore this ratio have to be dimensionless. And if this is the dimensionless, therefore we can invoke that this is kind of some kind of dimensionless density. So if you add this dimensionless density, they will all be equal to 1. Correct? Now here they are saying that suppose we don't have the q term, therefore we can say that this rho c is equal to 0 or rho phi is equal to 0, or they have already said that we have invoked the q term here, but as we can write energy density for the background fluid In background field, there is no any interaction, therefore we can easily write rho dot is equal to minus 3h rho plus p, correct? And p is equal to omega into rho, so this equation will come out to be 1 plus omega into rho. So what is actually happening is that because of this q term, this omega term will get some kind of modification. Therefore, because of this, we can write that the modification in omega corresponds to dark matter will be omega c effective, and dark energy corresponds to omega phi effective. And if you will compare these two forms with equation number 3 and 4, there here and here, and just compare it, make it to q to be like q can be written as some kind of something into rho c. Okay, so you can easily say that q is omega c effective is equal to q by 3h rho c, and similarly omega phi is equal to q phi minus q by 3h rho phi. So there is no any harm on it. Okay, just they have what they have did, they have just, if you are taking the minus 3h common, therefore you will get this thing, let us say rho c also, so you will get 1 plus q over 3h something like rho c, something, isn't it? So that is the thing, they have already done it. Okay, so here they are making some mathematical formulation to make it looks not formidable, and it will be easier to study. We have already think here, like suppose q is equal to 0, therefore q have to be in such a way that dark matter has to be decay with a to the power minus 3 or faster than a to the power minus 3. So a to the power cube is suppose like this, therefore it has to be kind of very steep. Okay, so that is the thing. We have talked about the Hubble tension, isn't it, that if you are taking from the CMB, you have the problem of H0 there, and SNI1, when we are talking about the seeing the supernovae, the H0 is coming out to be different. So they have suspected that, okay, whatever we are inferring from a lambda CDM model, basically the decaying in the matter portion is kind of maybe very faster. Okay, or we can say that if it is getting some faster, therefore dark energy could be more faster. Okay, so because in lambda CDM omega is actually saturating towards -1, we are suspecting that it should be like negative of less than -1. Okay, it will be great. Okay, now we have already talked about the dynamical system, that how we can construct a dynamic system. Everything must be from the dynamical variables which are dimensionless. You can read more about it through my video and you will understand it. Okay, now here, to understand the Q, you have to, first of all, there is no any other way we can understand more about the Q. This Q can be invoked through phenomenologically. Some have some kind of interaction, have the very physical motivation, or something like some you can construct by your own. You can say that there is some kind of a constant, there is a kappa to make it dimensionless quantity. Rho c is corresponds to the fluid. We can say that this Q has consist with some fluid density and as well as some energy density from the field. Okay, so what they have done is that they have considering the rho c from the dark matter fluid, and they have said that, okay, there is something like phi dot, okay, the kinetic part of the fluid, and there is nothing else. Second Q, they have chosen that this Q must have like Hubble parameter and then only dark matter, and there is no any way. So they have not included any kind of phi term here. Now if they have included the phi term, there will be the complexity of the dimensionality of the autonomous equation. This equation is called autonomous equation. If you have written x, y, and y dot is equal to f g comma x, y. So if you have any kind of phi term here, the dimension of the autonomous system will automatically increases. And in order to avoid that, they have chosen this way. So the thing is that the choice of interaction, it depends on you, how you gonna study. You wanna study in a nice manner, or you can study in a very different manner. You can also study, instead of rho c, you can also invoke n. N is a number density. Okay, so it depends only on you how you gonna take it. Then they have said you that, okay, alpha is greater than or beta is greater than. These are the parameters through which we will understand more about the dynamics towards. Now there is another way. You can also say that Q, the term, is having the two densities like rho c plus rho kind of x, and this x is corresponds to dark energy. So now they are exchanging from it. When energy density, you already know that in the earlier time when the universe was dominated with radiation or dark matter, the energy density of the fluid is very low. So we have the interaction term very dominated with rho c dark matter. And when when the universe was dominated by dark energy, this is kind of zero. So in such a way that there is some kind of transfer of energy from this sector to this sector is continuously happen, so that their decaying process is to be fast. Okay, so just like suppose you have the two rivers, and that these two rivers are actually interacting with each other. So if they merge it, therefore the fluid is actually flowing one river to another river depending on their pressure. If the pressure difference is low, the fluid will flow from high pressure to lower pressure, or there could be some kind of mixing of the two fluids. Correct. Now we are going to neglect the baryon, which is kind of radiation, and the matter we are not neglected. We are saying that since our universe is dominated by dark matter, which is 27% in our universe, and a kind of 72, yeah, maybe 70%, 70% dark energy. Okay, so we are considering that omega c is kappa square rho c by 3h square, and kappa square rho phi over 3h square is 1. There is nothing into it. So now we are seeing everything in terms of dynamical point of view. Now what happens to rho omega total? Omega total, we have the pressure of two things. What are the two pressures? The pressure of the cold dark matter is 0, and pressure of phi is phi, or whatever this is, the p phi. And rho total is consist of rho phi plus rho c. Therefore we can have the effective omega total. The system is now composite of two things, so we can define omega rho p total by rho total, which is come out to be omega phi, and this is bigger omega. And then similarly we can say that in total the system will decay in this rho total dot plus 3h, because in total we have already said that this is always followed because of the Bianchi identity of the geometry, G mu nu, Einstein's tensor. Now in order to study, we have invoked two variables x and y, and this y consists of v, and v has only dependent on the field, and x has the dependence of phi dot. And you have to keep in mind that in our system we are having two independent quantity, phi dot and phi, which is same as if you are constructing the Lagrangian for the classical mechanics, when you can say that the position and the velocity are different quantity, or in Hamiltonian you can say that the position and the momenta are the two independent quantities. So you cannot say that dy over dt is going to simply x. No. Yeah, they are related, but they are related in the different way. So for these two things we are defining two separate variables. Now we have omega phi. Now how our system is kind of omega phi plus omega cold dark matter is equal to 1. Now this omega phi is consist of phi dot and v phi, therefore it is consisting of x and y. Correct. Now you may see already that rho phi is equal to what? Half phi dot square plus v phi, and if you will write, it is coming out to be x square plus y square. So this is giving you x square plus y square, and then omega c is equal to 1. So we can say that if I know these two quantities, I can easily find out omega c to be 1 minus x square minus y square. So if I know the dynamics of this sector, I don't have to care about this omega c, just negative of this one. Now one more thing, the cold dark matter have the constraint. The constraint is coming out to be this density cannot be negative. This has to be 1, because we are defining everything in the dimensionless characteristic. So this omega c is to be 1. Therefore omega phi, whatever the omega phi, they have to be between 0 and 1. You cannot say that energy density of the field can be negative. No, pressure can be negative, but not energy density. So in this language, when we have translated, the translation goes this like omega total is x square minus y square, not this one. We are not only talking about omega phi, we are now dealing with omega total. And similarly, the Friedmann equation in this form, the second Friedmann equation, using the first Friedmann equation you can write in terms of only x and y. Correct. Now we are introducing the coupling term. Now coupling term has rho c and phi dot. You can simply say that kappa square rho, kappa is 2 by 3h square will be 2 by 3 kappa beta. They are the constant. And you can say that, okay, not kappa. Let us say only kappa, rho c, and therefore 1 kappa is again here 3h square. So kappa is square rho c by 3h square will become what? 2 by 3 and beta omega c, and therefore phi dot. We have already phi dot. Phi dot is corresponds to x, and this phi dot has some kind of h. You can understand more about, we will later on more understand it. This phi dot can be written in terms of x, and omega c now can be written in terms of 1 minus x square minus y square. So when you now take the derivative of this thing, now first of all, if you have the x square, taking the derivative 2x x dot, and this will become, the right hand side will be 2 phi phi double dot, and this phi double dot can be given by this equation. We have already the field equation here, and this field equation have q term. So in order to find the x, we have to replace q, and replacing q means that you will can write in terms of omega c. Omega c can be 1 minus x square minus y square, and phi dot in terms of x. Therefore whenever you are seeing this term, this is corresponds to only rho c. And this is lambda square root of 6. This lambda is telling you about the v phi, and y is also v phi, and minus of 3x. And similarly you have to take dy by dt, d2y by dt square. So y prime, and why y prime? So basically when you are taking the derivative dx by dt, there is some kind of an h term in the numerator. Okay, and when you, because h term is not kind of dynamical variable, and h is kind of very increasing function. So what you can instead say that, okay, I am defining the new variable h dt can be translated to be dn. How? Since h is dA by dt into 1 by a into dt, cancel, therefore d into log a. So d into log a can be written as dn. And the log a, this is the a is an increasing function because a is a scale factor, and we are seeing that when universe was very small, a cannot be 0. A will 0, therefore the universe will be collapsed. So a is kind of very expansion function. So now you can understand also cosmic time also, that in our universe time is not reversible. Everything is going from past to future in such a way that dt is a monotonic increasing function. Therefore since h is also increasing function, dt is also function, therefore h into dt will be always increasing function. So we can always define it in terms of dn. So I can write in x dot is dx by dt, therefore they have written dx over dn to be x prime, and similarly y prime. Okay, that is the motivation behind this. Now you will understand these technicalities when you will actually doing the research and do calculation by every steps. Then you will more understand about that actually what going on in technicality. So if you not understand the technicality of the subject, then I won't say that you will enjoy the subject very well. But here I'm trying to present you everything in very short time, that how you gonna understand the research paper. Now you can have different parameters, like b is lambda minus square root of 6 by 3 beta. Why b they have defined? B is a dimensionless parameter. So we can have something dimensionless in our system. We can always, because lambda is dimensionless, beta is dimensionless. So if something coming out to be dimensionless, there is no any problem. Or you can have the bunch of quantity which can be written in terms of x and y, then we don't have any problem. Therefore here they have already written that b plus minus something like this, b plus minus y, because there are two roots. So they have defined these points, okay, these points to be b plus minus, and there is no any scope here, I think. So table 1 has been summarized in a perfect way. Now when you solve, now our first of all we have to find the fixed point from this x prime and y prime, and in order to find the fixed point, what you have to do is that x dot is equal to x prime is equal to 0, y prime is equal to 0. It means that the right hand side should be equal to 0, and from here you will get that you have kind of 6 critical points are called fixed point, and these fixed points coming out to be some called 1 0 minus 1 0, and then you have some different parameters. You can see alpha, lambda. These alpha is corresponds to this one for model 1. Okay, so here is only 5 critical points, and this is lambda, this is b, and b is here. They have defined what is b, and similarly you have the e is from the beta. So we have these two couplings. Okay, And here b and b plus minus are defined in equation 3, so they have done a mistake, so you can have this b and b plus minus here. Okay, so everything is written in this way. Now you can see here that stability, we have already talked about it, how you can find the stability. Stability can be found by linearizing it with some kind of, suppose this is your critical point, so the function at critical point is always be 0, they have to be 0 because that is the way we have done it. And then now df over dx at the critical point. Okay, and from here they will make a Jacobian matrix. The Jacobian matrix is coming out to be, let us say, df over dx, df over dy, and then again dg over dx and dg over dy. Find the eigenvalue, and if eigenvalue is coming out to be negative, therefore we can call it the stable. If you have 2 by 2 matrix, there will be 2 eigenvalues. 3 by 3 matrix, 3 eigenvalues. If both of the eigenvalues are negative, you have the stable critical point. If none of the eigenvalues are positive, are negative, all they are positive, therefore they are unstable. And if they have the alternate sign, suppose minus plus, then they are saddle. It means that the critical point, you will first that some vector quantity are first attracting towards it and then finally repel towards it. So it has some kind of an unstable point, but not totally unstable. It has the saddle kind of property. Okay. So they have given that what are the conditions for which they will become stable, and corresponds to this critical point. They want to analyze that what are the cosmological parameters. Like cosmological parameters, omega phi is the cosmological parameter, means that we are talking about the energy density of the field. If you know the field energy density, which is coming out to be 1, so we already know that omega c is equal to 1 minus omega phi. 1 minus 1 is 0. It means that this point is talking about the dark energy era. Okay, and again, if it is corresponds to dark energy era but it shows no acceleration, we can say that this is not a valid fixed point. Simple. So from here we can easily understand more about these points. If you don't evaluate these parameters like energy density, omega total, you will never understand how will you gonna interpret these points. So these are more important things. Now they have given some kind of a graph that where these regions will be stable, because you see here that for the corresponding D point, D has the various thing, like it depends on the B, and also it depends on the capital beta, small b and capital B. So because of this, they have plotted the contour plot for beta and B, and they have found out the region that for which values it will show you the stable thing. So D point will be stable for different things. So it is very easy to interpret it. So that is the thing. From the table you will understand it which one is. So I think D is the most valuable point, and because it has, because E is showing no acceleration, AB is showing no acceleration, no problem. Now C is showing acceleration, but lambda square must be less than 2. Okay, and again D point is showing acceleration if beta by B is less than -6. Now, if some point is not showing acceleration, it means that their omega total will be 0. If omega total is 0, it means that they are corresponds to dark matter point or the unaccelerated universe. So they have the physical meaning. And with these points, it may show the acceleration. Therefore, we can say that this is corresponds to the dark energy point. Okay. Now we have the another coupling, and this coupling is introduced like alpha H rho C. Okay, and now they have done more analysis here for the model 1, that omega phi is less than 1 and omega total is less than minus of 1 by 3. We have already talked about that omega total must be less than minus 1 by 3. Okay, if we have the perfectly is accelerating solution, and we already know the from observation that omega total must be less than even -1. So first of all, our idea is to produce that can our analysis can produce -1 or not. So from here we will see in a minute that yes, we can have the acceleration greater than -1. Now you can also see from this table too that omega total is square root of 6 by B. In order to have negative of -1, what you can do? You can have that beta to be -3 and B to be square root of 6. Okay, so it will perfectly all right to choose this one and omega total to be -1. And beyond and corresponds to this, if you will choose, let's say, -3 to be -4, then you will omega total will simply go less than negative of -1. And they have already said that this is stable if B square is less greater than 3 by 2, it is stable. So I think this model is pretty can produce the acceleration beyond negative of -1. But you may say that hurrah, we have done it, we have produced the phantom omega total to be negative of -1. So our job is done. Well, we don't know for sure what kind of dynamics, what kind of, there is a structure formation. There is another observations like CMB and SNI1 data or SNI1 observations. So it is a kind of speculation. It is the thing is that we want to understand about the dynamics, but we are not sure that this is the exact way our universe is working. This is the phenomenological model. This has the mathematical, properties, but for sure we don't know. But yeah, it is amazing that the simple model can exhibit this kind of scenario, and the corresponds to the fixed point is stable. Therefore, yes, it is hooray, and we are done. But again, we have different kind of coupling here. The coupling with consists of only the dark matter density and H. And again, we have the pretty much interesting scenario here, alpha, because alpha is corresponds to this model. So they have found that some kind of relation between alpha and lambda that corresponds to lambda and alpha. There is some kind of a dependency between E and F, or maybe 2. Yes, you can see the figure for this 2. Okay, now again, simply we have the coupling model 3, Q is equal to gamma LC, and for this coupling scenario, this gamma, okay, so this gamma is can be like this, alpha C rho C plus rho X. Okay, and if you are defining the rho X, then rho X have the consistency of phi dot square plus V phi. And we have talked about that if you have the system in V phi, then you have to define additional variable like Z. So corresponds to this coupling, our system becomes 1 dimension to 2 dimension to becomes 3 dimension. You can see here. So for that, in order to compact the Phage space, they have to redefine the variable called Z in this way, because if they won't define it, they won't get it. And they have defined the one more dimensionless quantity. So dimensionless quantities, they are fine. Gamma is equal to gamma by H naught, and H naught is the today's value, which has some kind of value here, and gamma is some kind of maybe constant which is determining the rate. So Z is, they have the another variable they have to introduce here. So for this, they have found the 38, 39, 40 autonomous system, and you can find that they have said that if you take lambda goes to minus of lambda, y goes to minus of y, their autonomous system is symmetric. It means that there is some kind of an invariance in the autonomous system, which is very amazing. If Z goes to minus of Z, you can see that here there is some sign changes. Okay, but here y is going to be minus, and here y is going to be minus, and d of minus y by dt. So here is everything minus, and minus will cancel out. So this is perfectly all right. Whereas this may not be, because this will become 1 plus Z. So you can't cut it out. Similarly, for X will be some problem, because X is minus X, and here minus X, and there is also minus X. So if you will take here, so I think there is a problem of negative here, and we can't have we cannot have the invariance in the X. Okay, so we have to see it. I have not seen it, but yeah, they have some kind of a scenario that only y is coming out to be negative, while another components are not invariant. So what kind of symmetry it is possessing? So you can see that the symmetry they are position is that x, y, z is a cylindrical kind of symmetry. And you see they have plotted the different points like A, C, B, D, and they are saying that how these the trajectories are evolving from one point to another. This is called the Phage space trajectory. And for another model, they have found this one, the two-dimensional models, that how this two-dimensional is actually happening. So in the curve, there is some kind of point, and if on the curve, if you are getting some kind of critical point, we can say that this is corresponds to the field point, and everything is all the trajectories are going from these two endpoints, and these two endpoints are probably corresponds to dark matter portion, and they are going towards here. So it is showing you that universe is actually evolving from non-accelerating region to accelerating region. And here are several other points. Okay, so it is rich in dynamics. Here you have only two things, like omega total is equal to 0 and omega total is equal to less than minus of 1 by 3. But here could be some points corresponds to inflation, some points corresponds to maybe phantom, or some points corresponds to omega total to be minus 1. So we have to see it, that what kind of things it is saying. And now you can see here, more for model 3, we are getting like of 6 or 7 kind of 7 critical points. Okay, and it is completely rich with parameters. So it has the mode dynamics. Similarly they have different approach, that what happens if g goes to 1. So when you have taken g not to be 1, z sorry z not to be, then therefore z is going z have two values only. Z is either 0 or either 1. So they have shown that if what happens if you are going far at z. Okay, far, and what is the meaning of z goes to very far? We can say that z goes to be infinity, h0 is constant, 1 by h goes to infinity, which means that z goes to 0. Okay, and we can say here that z is always between 0 to 1. So h0, if let us say h is very small, then we can say that z is equal to h0 by h0. So z can be either 1 or 0. So z has to be between 0 and 1. Therefore it possesses some kind of cylindrical symmetry, and we have already talked about that in between y is let us say here they are opposing some kind of a symmetry, because they are invariant. Y corresponds to minus y invariant, therefore they have not plotted minus y, and they have only plotted like x, and here is minus of x, and here is z. Okay, so this is the very technical details here. Now again you will see the dynamics here. So for different gamma, they have plotted the different phase space, and this is gamma for 10 to the power minus 6, lambda is equal to 1. Okay, and figure 3, and here lambda to the power minus 6, lambda to the power 4. Okay, so different things, and they are actually trying to investigate what kind of dynamics is playing. Okay, so from here table they are giving you the eigenvalues, and you can see here this is completely saddle. If lambda, if this quantity is greater than 0, sorry, greater than 3, it will be coming out to be saddle. But if is not 3 minus thing is less than, okay, let us say it is greater than 0, total thing is greater than 0, therefore it is unstable, it is completely unstable, and it may be saddle. Again, it may be, it is saddle, and it is stable. These points are stable depending on, because here if you are trying to see the lambda to be fixed in such a way that this guy is a negative, this guy will coming out to be negative, then we can say that these 3 points can become the accelerating point. Okay, so not too much analysis here done, and I think you should read the paper here, and I have given you so many things, so many details, technical details about this paper. So that is the way to do paper. You have to have the background knowledge of minimum, then you can understand the paper, and this paper is very interesting to start from here. Okay, because there are so many different ideas of interacting fluids, so it is depend on the interacting field fluids. We will talk more about in the K-essence also, how the interaction between K-essence and fluid take place in the general format. Okay, so I hope you like this video, and if you like, please thumbs up and share to your friends, share to your students and so on. So this is Untitled Chapter signing out.